Okay, sorry about that. My projector turned off randomly. So picking up, I don't remember, unfortunately, exactly where I left off. So I know that because I put this +1 here, that at least, if nothing else, I was saying this. When I see maximums and minimums, I usually skip that, do other parts of the problem, whatever I can think of, and then I come back to the maximum minimums afterwards. But I do always do two things. One, I definitely set the derivative equal to 0 because a lot of times that's its own point. And two, if it's relatively easy, I do find the values for t that would make my derivative equal to 0. So like if it's a quick factor and solve, I'll do that too, because sometimes those are their own points. Unfortunately, this particular year, it wasn't its own point, but sometimes it is, and so I'll do that. But I save all this work of plugging into the original equation for the end, because that's usually a lot of work for really only 1, maybe 2 points. And when you think about 1 or 2 points in the context of the whole problem, especially for how much time this takes, it's better to spend your time on stuff that maybe is a little bit faster, and rather than spend a ton of time here, maybe make an error, lose points, and lose out on those faster points, right? But you can develop your own strategy according to what you feel like you need, okay? Okay, so 1 point was for setting the derivative equal to 0, 1 point was for your answer, and 1 point was for your justification, which, a reminder one more time, explain always means work. Explain always means words. Justify could be work or words, depending on which one is most applicable and which one is most thorough. So if you think your work does not fully support why your answer is your answer, then add some words to it. If you've got extra time at the end before your 5 minutes for upload, add some extra explanation in, right? So make sure you are being as thorough as possible. Okay, last one. The pipe can hold 50 cubic feet of water before it overflows. For time t greater than 8, water continues to flow into and out of the pipe at the rates already articulated above. Write, but don't solve, an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. Okay, so we're talking about water inside of a pipe. It'll start to overflow at 50. And so we're going to write an equation here. There are a variety of equations that work. This is mine. Water inside the pipe, that's the amount of water inside the pipe, right? 30 plus the integral of r minus the integral of t. 30 plus the total that flowed in minus the total that flowed out in words, right? So we're going to write that out. That's what's inside the pipe. Okay, so that involves an integral, right? Involving one or more integrals that gives the time w for when the pipe will begin to overflow. So when will this begin to overflow? Well, when the amount inside the pipe equals 50, which is how much the pipe can hold before it starts overflowing, that's the time when it will begin to overflow. So we're going to call that w because they said to. Okay? And so that's my equation. Again, there are other ones. If you came up with a different one, send it my way. I'm more than happy to check it for you. You got 1 point for your integral, which I had 2, but you only needed 1. Again, I'm going to upload the rubric so you can see how they did it. They actually combined these two ideas. And then 1 point was for your equation. So I had the 30 and equal to 50. Another thing you could do potentially is subtract the 30 underneath. And so you'd have the integrals equal 20 if you wanted to, and that would also work. Okay? Okay, one more here. So pause the video if you haven't already. Try one on your own. This comes out of 2017. And then restart it when you're ready. Feel free to fast forward through my explanations if you feel like you're kind of getting bits and pieces of this. Again, I'm not looking to waste your time. But I am wanting us, like I said several times, to review especially some of the vocab and to practice our testing strategies. That's the focus of these types of problems. Okay. So here we go, 2017. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by f of t, where t is between 0 and 12. F of t is measured in pounds per hour. T is the number of hours after the store opened. After the store has been open for 3 hours, store employees start adding bananas to the display table at a rate modeled by G of t, where t is between 3 and 12. G of t is also measured in pounds per hour, and t is the number of hours after the store opened. Okay, so again, one more time. When I start seeing comparative rates like that, there's my table, I always look for those different attributes that we wrote down in the notes at the beginning. So what's going on to my table? What's going on to my table is G of t. Okay, so this is G of t here. Now, sorry, t. Make sure you take note of the fact that we've got bounds of 3 to 12, so not 0 to 12 for that one. Coming off the table is our F of t. It has different bounds, 0 to 12. And on the table already, we started with 50 pounds on the table. So if I'm talking about on the table, its derivative would be G of t minus F of t, recognizing, though, again, that they have different intervals there that we'd be considering. And if they're talking about the amount on the table, it would be the starting amount 50 plus the total that got added minus the total that got taken off. Okay? We've got some units here in case we need units. Okay, A. How many pounds of bananas are removed from the display table during the first 2 hours the store is open? Okay, so how many? What's the total number? So total, again, is an integral. Bananas removed from, so what's going inside the integral? Well, removed from is just the F of t function. And it's just the first 2 hours, so we're talking 0 to 2. So then you pick up your calculator, you'd plug that into your calculator, and you'd get 20.051. They don't say to include units, so we're good to go, but I'm going to go ahead and put pounds. Okay, this one was worth 2 points, 1 for the integral, 1 for the answer. Okay, B, find f prime of 7. Okay, so again, I mean, this f prime would probably surprise me if it showed up as a non-calculator this year. I mean, because you've got product rule, you've got the chain rule. But that's how you would take the derivative if you had to. Obviously, again, this year they had the calculator to aid them in their derivative. But if you were to take this derivative by hand, you'd have to do 1d2 plus 2d1 and do chain rule here. Again, that would probably surprise me, but a good thing to maybe walk through and remind yourself of if you do want to do that. I want to send a picture of your derivative by hand, and I'm more than happy to check it for you if you'd like. But we obviously, this particular year, 2017, would have used our calculator and would have gotten negative 8.119. Okay? And so then explain using correct units. So first of all, let's start there. What would my units be? Well, F, remember, F was pounds per hour. And again, one more time, when we take a derivative, you add a time unit. So if F was pounds per hour, F prime would be pounds per hour squared. And then explaining the meaning. Okay, well, it says derivative. What's the word for derivative, or a word for derivative? Rate. Okay, so f prime of 7. Actually, no, I'm going to say this. Let's say we're going to describe f here. The rate at which bananas are being removed from the table. So again, that's F here, right? Customers remove bananas from the display table at a rate. So I've just said F is, I'm going to say decreasing, so I won't use the negative, is decreasing at a rate. So that's my F prime. That's the prime bar, right? F negative prime of 8.119 pounds per hour squared at 7 hours. Okay? Or maybe at 7 hours after the store opens, after store opening. I'll add that in as well. Okay, this one was worth 2 points. I seem to have lost my red pen, probably when the projector died. So I'll just notate it in, oh no, because I used red pen up here. I don't know where my red pen went. Sorry about that, guys. We have 2 points here. I'll notate it in blue. 1 point was for your value, f prime. So I'll put it out here to make sure it doesn't look like my work. 1 point was for my answer with reason. Okay? Okay, C, is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? So again, how do we find whether something is increasing or decreasing again? Okay, well, it's whether your derivative is positive or derivative is negative. Okay, we're talking about on the display table, so what kind of derivative are we using there? Remember, on the display table is our g of t minus f of t. Okay, so we're going to do g of 5 minus f of 5. Plug that into your calculator, and you should get negative 2.263103. So what are we doing? We are decreasing because g of 5 minus f of 5 is negative. Well, there's my red pen. Okay, this one was also worth 2 points. 1 point was for considers f of 5 and g of 5. 1 point was for answer with reason. Okay, D, how many pounds of bananas are on the display table at time t equals 8? Okay, well, the total number of bananas on the display table, so again, a total, one more time, is an integral. That's what an integral is. It is a total. And so on the display table at t equals 8 would be this guy here. Okay, that's the amount on the display table. And so we are going to do our 50 plus our g function. Now our g function, remember, started at 3, not at 0. Right? Started at 3, not at 0. Minus our f function. And we take that and we plug it into our calculator, and you should get 23.347. Okay, this was worth 3 points. 2 were for the integrals, and 1 was for your answer. Okay, so that's your kind of, I guess, little lesson into accumulation. And again, like I said at the beginning, the reality is that these problems, exactly as they show up, or as I should say, exactly as they have shown up, would not be on this year's AP test. However, bits and pieces within these problems could be, right? The idea of being able to take a derivative, knowing what a derivative means, being able to do average rate of change, being able to integrate something, knowing how to navigate units potentially, right? So like all these bits and pieces, this vocabulary, this idea, or these ideas, knowing how to find maximums and minimums, everything that we've looked at over different FRQs, they could be there. And so it's important that we review that vocab stuff that are contained within each of these parts, as well as, like I've said many times, continuing to practice our testing strategies, which is when you hit a piece of a problem that is more challenging, not letting that throw you. It's going to happen. You're going to hit maybe part C and have it be hard, and you can't let that stop you from continuing, from moving on. College Board has reiterated several times that students need to make sure you are prepared that you might not finish the problem entirely, but you upload what you've done, right? You can't let it throw you. Okay? if there are questions on any of these problems in particular, or if you're wanting more information other than what I've shared about the Unit 8 that has been cut, or whatever the case may be, any question you might have, send it my way. I'm here to support you still. Okay?